Hey there guys, welcome to the stream. Just gonna make sure some things are up and running and then we'll get started. I'm really hoping that the quality is a lot better than it was last night. I even kind of like unlisted the video because it was just unwatchable because the video quality was so laggy. I mean the audio came out, but I'm really hoping because I've got a different setup now for tonight. I'm just hoping that things are a lot smoother on the video end of things. So let me just make sure. Um, Just gonna quickly check this is running. Excellent. Alright, I think the video quality is somewhat smooth, hopefully. Get started in a sec. Uh, I will just quickly do a bit of housekeeping on my end. Right. Just 2 seconds, guys. I say 2 seconds, it's gonna take a little longer than that, like 1 minute. Alright, oh, that's not right. Let me just grab this. So I might as well let you guys introduce what's going on. So what we're going to be doing is coding a 2D video game using C#, more or less from the ground up. And we're going to be leveraging the Win2D runtime to help with the immediate mode 2D graphics. So it just gives us access to some libraries, or rather it's an abstraction. I don't even know if we use the right terminology. And basically, we have the prowess of DirectX API. Basically, what it lets us do is code C Sharp, and it's a step up from GDI, which is what you would have probably be using if you were trying to code 2D graphics in WPF or WinForms. So it's definitely a step up. I used to use quite a bit of GDI and GDI Plus, I think, and now I'm a lot more into like DirectX side of things. So Win2D does intrigue me. I'm just gonna quickly share this link on one of my handles, and then we'll get started. Hopefully we can get through as much of the agenda as possible. Just gonna do this. And always been fascinated by 2D games, 3D games as well, just gaming in general. So I'm always fascinated to do a project like this. Okay, nearly done. Alright, so that's done. And let me just change the screen. Okay, about done. Hey guys, welcome to the stream. Thanks for tuning in. My name is Will, and this is just going to be a chilled session where I'm going to be coding in C Sharp using the Win2D runtime. The aim is to make some form of playable 2D game. I'm aiming to make like a platformer style game, And yeah, so let's just dive straight into things. So we're starting with a blank canvas, and just so you know, I did want the camera angle to be like here, somewhat in front of me, but because of the nature of my setup, I couldn't do that. So I do apologize if I'm kind of sideways and you can't really like see me straight ahead, but it doesn't really matter. If anything, if the audio is weird, too quiet, too loud, do let me know. I'll just quickly check if anyone's letting me know. No problem. But if there is any problems with the video or the sound, do let me know. Yeah, let's just jump straight into this video. So, let me minimize my off screen. Win2D, best place to start is what I've already done ahead of time because my computer is a little bit slow. I've gone ahead, let's see if I can get it up quickly, to Tools, NuGet Package Manager. You want to go to the Manage NuGet Packages rather for solution, and here you can download the Win2D runtime. Now, I'm just hoping this doesn't freeze up too much. Okay, it's coming out okay. So I'm doing this on the UWP, so I'm targeting the Universal Windows Platform. It targets Windows 10 and I think Windows 11 as well. But then Windows 11 might be using a different sort of front end for their apps. They may be flagshipping. I don't want to get it wrong, but I think it's like the .NET MAUI platform or WinUI 3. Not too sure. I haven't really used much of that, but it does sound super exciting. I do kind of follow what .NET does and Microsoft these days. It's really cool. I'm not affiliated, just saying. But anyway, so yeah, make sure you have Win2D installed for your package, for your project rather. And I always tend to update this Microsoft .NET Core Universal Windows Platform package that's already installed, but you want to make sure you update it because I think what it does, it addresses some bugs that that tend to happen when I used to work with UWP before, but now I find UWP is a much more stable platform and it's very viable in my opinion, and I do have quite a lot of fun with it. So let's start with the basics. We have here a blank C# file. This is the main page, and this is where we're going to be kind of dispatching the majority of our logic towards different bespoke classes. And what I want to do first is just hop to the XAML. And if I just quickly, I've got a few notes from some older projects, and if anything, we'll just follow the documentation most likely from MSDN if we get stuck. But what you want to do, I've already made a video about like the basics of getting started with Win2D. But on the XAML, you want to make sure you've got the correct namespace. So I'm just going to go ahead and copy this from my other project. I have a namespace defined. Every time I go to the designer view, my laptop just gets a little bit laggy. So hopefully it won't be too bad. There we go. And I'm going to just paste that in. So I've gone ahead and I've defined an XML namespace, called it Canvas, and it's targeting using : Microsoft Graphics Canvas UI XAML. Now under this namespace, we can then access the Canvas animated control. So I do tend to like to work with grids, and to be honest, when I work with XAML in UWP, I tend to work with grids as a sort of the overarching parent container for my UI, and I do like to use view boxes. I made a little video about that, which you might find on the you would find on the channel, should I say? It's not hidden or anything. And I talk about just like how you can use the view box to kind of help to create responsive UI, because I think it's a fluent user interface control. I'm not 100% sure. Have to check the documentation on that. But I think view boxes are fluent, so it has a it has a certain capacity of responsiveness to it, which really does help. We're not going to worry about that right now in this particular project because we're going to be using the canvas animated control. So as you can see, hopefully it's visible on the IntelliSense. There's a canvas animated control which we're referencing here from our canvas, the name of our canvas reference. Let's go ahead and give it a name. So let's just say x:name, and let's just call it something simple. Canvas animated control. If you see my other videos, this is fairly standard. Canvas animated control, and let's just go ahead and close that off. Oops, it's a bit hard because I'm sort of sideways trying to type. So anyway, so we've gone ahead and defined this, and what I tend to like to do is to just give it a few dimensions. And I got a little bit of an agenda, so we're going to just go through that. It's on a separate page, so I'll just show you so you have a rough idea what we're doing. Let's give it 720 for now, just so we can see what's on the screen. You can just about see the bounds there. And I'm going to go ahead and give it a width of 1080. And I'll just stretch it out on via the kind of drag and drop on the designer. Just want it about here. Now, one thing to note is, one thing I do like about UWP is the fact that it does target a range of different device types and target device resolutions. And I suppose it does help because with WPF, I mean, what I did like about WPF is that you had more freedom in terms of the scaling just right off the bat. But here it's a little bit more preset. So you have these different targets, and depending on what devices you are targeting, you have like this kind of base resolution you can go for. I tend to stick with 100% scale, a 1280 by 720. So I'll go ahead and just change that. Excuse me. So I think that's fairly decent if you're targeting like maybe a laptop-based experience. I'll just make sure. Okay, so my bounds have changed, but I think I can still. Yeah, that's completely fine. Go ahead and save that, and that's about it. So with regards to the game and the XAML in this project, this is about all we're going to be doing with the XAML. Maybe a couple things here and there, but for now we can just leave this. The majority, 95% is going to be in code. So I think a great place to start would be to just initialize three important events that we're going to be needing. And just to save time, to save effort, I've got some reference notes for my other project. I will just copy it in. And for the other logic that's a little bit more involved, I'll most likely be typing that myself. So the naming is wrong, I think. Oh yeah, one thing, we need to call a namespace here as well. I don't know if I can remember off the top of my head. It's probably the same as the XAML one. Microsoft. No, I got it wrong. Okay, let's just let's get straight to the notes because I don't want to try and look for this too long. It ends in XAML. Yeah, Microsoft Graphics. Okay. So we want Microsoft Graphics, Canvas UI XAML. So that will just import the, I think the Canvas animated control into the CSharp file. And I called it Canvas animated control. So I could just take off main there. And since it's within the scope of, it's within class scope, I can use the this keyword to just basically, oh snap, made a mistake. To just, sorry about that guys, the this keyword will just tell the program that this particular member is within class scope. So I'll just do that. I have a bit of a habit of doing that. Okay. So these three, these three events are events we're gonna need. They're create resources, draw, and update. And as each of their names seem to imply, the first one at the top here, let me just make sure this is visible. I'm gonna quickly hop to this other screen. It's pretty zoomed out. I just realized. So let me zoom in. And I'll probably just make this a little bit smaller, the window here. Zoom in. Okay, that should be a little bit better. Again, this is just going to be a chilled kind of stream. I don't know how far I'm going to get into this. Hopefully we'll get some kind of format of playable game. It will be really good. And I've done this I've gone to the point of like controlling characters, making parallaxing backgrounds. So if we have enough time, we should be able to get to that point without too much of a hitch. Anyway, so create resources is the event that is sort of the initializer of all of the draw logic that we need. I say the draw logic, but rather, let me correct myself. It's more for us to load all our bitmap resources, and it just loads it into the program so that we can then access it at runtime. So I'm hooking an event. I'm hooking a method to this event, and this is called create animated resources. Now, of course, we haven't made this yet because I plugged in the code for my other notes, and we also have respectively animated draw, animated update. The key difference between animated draw, animated update, they're both update calls that run at a target of 60 frames per second, according to the documentation. Last time I checked, which is really it's a good standard. It's basically it's a standard, isn't it? You know, you're not going to really need more than 60 frames unless you want to maybe target a higher frame rate for whatever reason. I'm not too sure if 120 actually makes a difference, but I think 60 is fairly good. And then the difference is they run on different threads. I think it's the draw and the UI thread. Don't quote me on that, but I will leave in the link, in the description, links to important resources, Win2D documentation, if you're interested in following up on this topic. So let's go ahead and just create these functions. We'll start with this one. So we got create animated resources, and just before I do that, just gonna quickly check my other screen. Okay, that's fine. And I think the connection is fairly decent, so I'm quite happy with that. Yesterday was quite bad. I had a worse setup than I do right now, but I decided to do a little bit more research and just improve my setup. It's amazing what a quick Google search can do these days. It's actually pretty impressive. Anyway, not sponsored. Just joking. Let's do this. So let's make a private. I would say async, but for now we'll keep it void and we'll just get the name. We have to make sure that the parameters we're accepting for this, for the construction of this class, is it matches the types that the event is expecting. And I believe it's the canvas create resources event argument. And I actually forgot what the first one is. If it's not this for the sender, it would probably be the canvas animated control. Let's see if I got it right. Graphics, I might not, just off the top of my head. Was it XAML? I think it's UI XAML. Because if the canvas animated control is the sender, it would make sense. That's what I'm passing. But I'm probably wrong. So if I am, I will just correct myself. And then I'll just save myself the time by copying this argument. I think I got that one wrong, the first one. Was it expecting? Oh, whoops. Canvas animated control. Okay, I think that's okay. Yeah, okay, so the program is okay with that. So what we're doing, we're passing the canvas animated control in focus that we want to target to load the bitmap graphics. And we're also passing this canvas create resource event arguments, which I've just, I'm naming a variable E, which will allow you to access the members of this particular class. So let's go ahead and deal with this function first. Now, if my memory serves me, which if not, I will just refer to my notes, what we need to create, and I would suggest, and again, the way I construct this code is not going to be optimal by any stretch of the imagination. I'll do my best to kind of separate the concerns in as much as reasonable, but just even to lay things out simply, I'll focus more on making sure the code is kind of readable rather than it being like too optimal kind of thing. I spend quite a bit of time trying to make my code more optimal. I don't want to spend that time doing that too much here because it can take a while sometimes when you really have to think about, how you're constructing the code. So what was it I was looking for? I've actually forgot the class. So I'm going to quickly check the name itself. It's a canvas bitmap, I think. Yeah, canvas bitmap. And let me just access that. It's under the Microsoft graphics canvas and then canvas bitmap, I think. Yeah. Here we go. And let's call it canvas bitmap object. And I'll just declare it here. Give it a quick comment. This canvas bitmap is used to load the bitmap graphic of a, let's just say, sprite. So basically what happens is we pass this into, we basically construct this in a particular way. If I were to try and construct it in the way you may consider, may or may not consider. But the way I tried to do it first, I don't think it worked. Is the typical kind of like use the new keyword and then you kind of try and create the constructor. It doesn't just quite work like that. And I always seem to forget off the top of my head, but good thing I've got my Notepad++ here off screen. Just gonna go to the construction of that class. Sorry, I said class of the method. Just very quickly, just so I can see my reference. I don't want to take too much time trying to work it out because I forgot off the top of my head. Ah, here we go. Yeah, that's right. So let's go ahead and reference this. Might as well reference it in the class scope. And we want to call a wait here. And since we're calling a wait, this has to be an asynchronous function. And you want to also, usually with async functions, I think the function that you call async has to be void. I think. Not 100% sure about that, but I think that's the case. But in any case, canvas bitmap object, we are passing a Microsoft Graphics canvas bitmap. Then what we do, we go one step further. We call the load async function. And here, what we pass is the canvas animated control and the file path of the graphic that we want to actually load. So I've actually ahead of time gone ahead and gotten the graphics that I'm interested in. And you may notice it from a previous video. It's like a bunny in like a hill and a meadow. It's kind of fun and I kind of like it. So let's use that. Let's see, canvas animated bitmap. I am passing that. So canvas, canvas animated control. So we want to pass our canvas animated control at XAML. Oh, that's not the right one. Sorry. Canvas animated control. Yeah, that's the one. And now the file path. Just a heads up, I would recommend, just from my experience, that you use the assets folder in the working directory of your project. And this is because if you want to, say, pass your project to another machine, you want to deploy or anything like that, then basically what you want to make sure is that all the assets and all the dependencies with regards to resources and stuff can be accessed within the scope of the actual project. So what I tend to do, and I'm off screen right now, and I'm just going to my file directory just so I can quickly show you guys, hopefully. If I can just quickly find where I saved this. Win2D platformer, Win2D? Yeah, that's the one. And heads up as well, I find that you have to build and run the project before the working directory, well, before one particular directory is built, and that's the directory I happen to use. So here, it's going to be kind of small because it's not really zoomed in even when I stretch the screen there. So I'll just guide you through. So I tend to go to the, you go to the project folder, then go to bin. Don't know if that stands for binary, but I always say binary these days. I'm targeting x86, so I go to x86 debug. And this doesn't appear before you build and run the UWP app for the first time. And once you do that, then the Apex folder actually appears. I tend to use this, assets, and I've already stored here, as you can see, rabbits, what does it say? Rabbit, debug assets, and backgrounds. Background is just some kind of textures that I compiled together in a simple image editor. Debug assets is actually just a line grid, which just helps me see the position of all the bitmaps on the scene. Because what happens is when you load a bitmap, you put it in a bounding rect struct, and we'll get to that part in this stream. And once it's in the rect struct, you can then define the height, the width, and you can also define the position value by X and Y. So what I did, I just went to an image editing software. I literally just defined via the pixels the same dimensions, at least as far as the pixels said, because I think pixels are kind of a relative unit. It depends. I'm not too sure about that, but it was fairly accurate. And I used it in a different project. So I have it here because it might be useful. I have rabbit. So I've got a very simple sprite sheet. It's just a rabbit. And this rabbit's got a few simple animations. I drew an idle animation, which is down here at the bottom. Simple left, right running animation. And obviously you'd want to kind of sprite batch this if you're doing any like proper um, games development and you're actually loading graphics. You have like probably a tile atlas and you have a single bitmap graphic, and it's somewhat a form of like effectively compressing the information, because instead of, as with my approach where I've got every single sprite stored as an individual bitmap, this takes up more memory, relatively speaking, than if you say have like one image with all of them and you just have an algorithm to crop every individual grid of bitmap, of the bitmap, to kind of like split the bitmap up. But I'm not going to go into that. I was looking into that for another project I was doing. It was the Slim DX one, and I did record a video for it actually. If you saw my Slim DX video, I got like two on the channel, or two or three. And I was working with trying to get bitmaps loaded, apart from single pieces of geometry. So hopefully I can make a bit of progress on that. I have been a little bit quiet on that front. I haven't been doing that for like a couple days. So I should really check it out because it is really fun. Anyway, let's get straight into this. So my working directory, I need to make sure I reference this assets and rabbit folder. So I want to load the background and I also want to load the rabbit. So we'll just bear that in mind. I'll just take this off screen. So when we go back to the constructor, constructor, yeah, I suppose we can say that. Is that right? I don't know if that's the right terminology. But basically, the parameters we're passing into the function, I think that's better said, is the file path. And so what I tend to do is use the working directory, as I said. So I like to use, I think it's called app domain, base directory. Oh no, sorry, it's current domain, then it's base directory, and this will give you the working directory of your project. And then I go ahead and I just add to this file path. What was it? Assets. If I spell assets right, I hope I did. And then it is, now the thing is, I won't write the whole string together as one. And I'm gonna get back to why I'm doing it like this. It will make a little bit more sense. I mean, at this point, it doesn't really make much of a difference if I'm accessing this particular folder. But when I'm loading multiple images, it's actually kind of convenient to have a particular convention to the way you name the sprites, the sprite images, the PNGs or JPEGs, whatever you're using, because you can then loop through them, and you can conveniently loop through them if you write the algorithm right. So what was the name of the folder? I'll get the backgrounds first, actually. And then I think off the top of my head, the name of the file we want is called forestbg.png. I'm going to double check that. So assets background forestbg.png. I'm going to just verify that's a valid file path. See if I can just squish that a little bit. So backgrounds, yeah, forestbg, and it's a PNG file. It's quite large. It's like 2000 by 1200 pixels. Gosh, there has to be somewhere I can like compress that or something like that. I don't know. It's quite a big file. That's why you'd probably use like a tile map instead of just like one image for one, sprite. But obviously, for the sake of time and effort, I'm not really doing that right now. Okay, so we also want the rabbit. So rabbit folder. Now, here's the thing. We want to load all of this, but we don't want to have like 20 lines of code doing the same thing. So just before we get to that, let's just finish up here. I want to add a list to just store our now basically our bitmap graphic. So what I'm gonna do, I will shortly create a list. We'll call it something like canvas bitmap object list. We'll just keep this at like field level. I'm not gonna make properties right now. So this will be a private. I forgot to give this a protection level. Might as well make it private. And let's make a list of Microsoft graphics, canvas, and I really do hope my tablet, which I'm using for the screen recording, or rather the webcam kind of thing, it might die out. It is charging, but I think the charge is a little bit offset by the amount of strain on the battery right now. It's doing quite a lot of things, but I don't know. It might be fine. I'll check in a sec if I can. Anyway, let's make a list of canvas bitmap. Canvas bitmap object list. Oh snap, what did I do? I pressed Control Z. I don't know what I did. I tried to press Control S and I missed S. I pressed Z instead. Where was I? Let's give this a comment. This list holds the bitmap objects of the sprites loaded at game runtime. Okay, now what we want to do with this, let's just construct this quickly, and we'll do that at constructor level of our class. So this canvas bitmap list equals new list. We'll just do it like this. Let me just see. Yeah, that's fine. And then we're just going to simply add to the list. Take a quick swig of coffee. I have to cut down on coffee. I drink quite a lot, but it's all good. Add, and what is it we're adding? So we're just going to add the canvas bitmap object. And I'm going to come back to this. It's going off screen real quick. Okay, no worries. And so, with regards to this canvas bitmap object, if I could just go back. Now here's the thing, I read up on the documentation. Maybe I'll get it up on the screen, because I think this is quite an important point to make. And I was victim to this, and the documentation shed some light upon what was going on with my code at the time. So I was trying to find the article. Let's see if I can find it. I think I searched something like Win2D e-drawing session, and I found some comments on the documentation regarding the canvas animated control. I can't find it right now, but basically you can, if you're not careful with the way you manage these canvas bitmap objects, you can get like memory leaks. And I'm trying to find. Oh, I've actually found it. Exactly this. So let me pull it up on the screen, because I think this is important, because this happened to me and I didn't know what was going on at the time. So I just highlighted the part of the documentation. Might as well make it full screen. Can I zoom in full screen? Excellent. So, and I'll just double check that's actually visible on the screen. Sorry about that, guys. So when using canvas control, let's just substitute canvas animate control, excuse me, as well. For managed code, so you know, CSharp, care must be taken to avoid memory leaks due to reference count cycles. See avoid memory leaks for more information. And what ended up happening with me is that I was basically saying, okay, one day I was just making a game, you know, I was just exploring Win2D, what it can do, and I ended up having like multiple canvas bitmaps all being instantiated. I was like, okay, that's fine. But then I was getting these exceptions. I was like, what's going on here? And I didn't know how to deal with them. And they were like memory-based exceptions or something, like I/O memory exception. I can't really remember off the top of my head. And I read this the other day, like literally yesterday. I was like, oh, so that's what was going on. So you really do have to be careful. I haven't had this issue in as much as... Oh, I just full screen my other screen. Let me just correct that. In as much as I made sure... Now, this is not really a fail-safe, what I'm about to say, but it did seem to help me. If you have, say, like 10 different graphics you want to load, you can use just one canvas bitmap object, or canvas bitmap rather, and you can just reassign it. And then what you can do is just save that instance into a list, and you can reuse the canvas bitmap object. Excuse me. Now, I don't know if canvas bitmap inherits from iDisposable, which means we can at least use the using class, the using keyword to manage our resources, which it does. And I haven't really tried doing that. We can maybe see like we can, if there's time towards the end or something, we can see what we can do with using just to make sure we're managing our resources okay. It's always good to have this interface, like have the members accessible via this interface. So it's good to see that it's got the iDisposable there. So with that in mind, I won't do it just now, just for the sake of time. But for the scale of the example I'm doing right now, that I'm demonstrating, I don't think it will be too much of an issue. So anyway, these two lines, basically, and I'm just going to quickly check because my camera just did something. Okay guys, I don't know if I'm still running. Um, my camera just did something weird. I'm using like an OBS router. I'm just gonna quickly check off screen just to make sure I'm live. And I think I still am, hopefully. So I'm gonna continue because I don't know, it just went black for a second. So apologies if the screen went black. Anyway, where was I? Oh yes, so I was talking about the this block of code. So I can't remember exactly where I was, I admit. But anyway, what we're gonna do here, we have various different graphics that we want to load. And if I just quickly go back to the file, the Solution Explorer, we have, you know, like 1, 2, 3, 4, 5, at least a dozen probably different graphics. Now, instead of line by line, you know, making the assignment and putting it into the list, I thought it might be a little bit more neat to basically just create a loop and just literally let the loop handle the legwork instead of typing it all out. So we know that we have here, hopefully it's a bit visible. It's hard to read, I do appreciate. This standing animation for the rabbit, I named it S0, and it goes S1, S2, S3, S4, S5, all the way to S8. So what I could do, so if I just make a quick comment here, load the BG background bitmap. Let me not be too confusing. Background bitmap. So we could say something like this. Create a for loop for int index is equal to 0, index is less than value, which I'm going to create in a second, index increments. And the thing is, I'm going to avoid magic numbers. I don't want just like randomly define numbers without any kind of context. So what I'll do is probably not the best way, but I'll just simply say, because you know your assets could change at any time during your project. You might have some 10 frames of animation for the running animation of your bunny or whatever your main character sprite is going to be. Mine is S0 to S8, so I think that's like 9. 0 to 8 is 9, 0 index inclusive. So what I'll do is just simply say, just so it's a little bit readable. Actually, no, let me make it just simple. Private int. We don't have to make it a const, I suppose. Doesn't really make a difference. And it's a value that might change. But let's just say private const int player one standing animation. No, not animation. Yeah, standing animation max. And I believe it was 9. So we'll just define this variable at field level and defines the maximum, it's not maximum, right? Amount of frames for the standing animation of the player. And this just makes it a little bit easier so we can kind of read through the code at a glance what's actually going on here. So we're just basically saying here that for within the range of 0 to 9, we want to execute some kind of logic, right? And the logic we want to execute happens to be what we've already defined here, really. So I can just copy that. I need to make sure that my file path is legitimate. So, excuse me, so we'll go for rabbit. Now the key here, let me just quickly double check something. Yeah, we have index. Okay, cool. So the key here is to say, okay, we'll look for the pattern. In this case, we have S prefixing some number, and it goes in chronological order. So we could just simply say something like, S. I think it was lowercase. Was it lowercase? Yeah, it was lowercase. S for standing. I think that was the reasoning there. Then we can concatenate the index, and we can just cast it to a string. And then we can just concatenate the PNG file extension. So I'll just quickly zoom out so I can see this, and I'll zoom in again. So what we're basically saying is, for between index 0 to 9, we want to basically access this file path, but it's going to be called, oh goodness, I forgot something. So rabbit is a folder name, so I'm just going to make sure I have I think is that forward or backslash? I don't know. I'm going to say it's a forward slash, a slash, this particular slash. We need to make sure we define our folders. So background and rabbit. And here it will be 0, then it'll be index, so it'll be S0, then it'll be S1, S2, S3, all the way up to 9.png, and then this logic will be complete. So instead of just doing like 9 lines of the same logic, why don't we just do 1 line of the logic and loop it? So that's what I've done here. So that's that. But now we need to actually deal with the other bitmap graphics. So what do we have here? I want to load as well the running animation and the jumping animation. So let's go for the jump because it's right up here. So we got J0 up to J4. So what I'll do, I might as well, just for the sake of simplicity, probably a more efficient way to do this with naming conventions, but since the naming convention does break a little bit, J0 to J4. So let's say player 1, and let's change this to jump animation max. Yeah, okay, and I'll just, in fact, I'll just use this. I'll change this const to player 1 jump animation max. Some coffee. So yeah, I believe it's 5 frames. Player 1 jump animation max. I'll double check to make sure that's 5 frames. 1, 2, 3, 4, 5. And one thing to note, if I load these frames as they are, the animations are going to be pretty fast. So I'm going to need to also accommodate at some point for in-betweens. Won't get to that just yet. But it's something I have noticed when I've done this kind of thing before with some of my old kind of play around projects, just to kind of explore Win2D and stuff, what I can do. So okay, we've defined a constraint, like a boundary for our range, 0 to 5. And now, in the same folder, but instead of S, we're going to replace that with J, because J stands for jump for the files, for the jump animation frames. And we want running left and right. Now, there is probably some kind of transform. I haven't seen it yet. At least I can't remember 100% off the top of my head, for probably mirroring the graphic itself. But for now, I just have two sets of, two sets running left and running right. Excuse me. So we're gonna use that. So player 1, let's say left run animation max. Haven't made that yet, so got error. And how many frames is it? It is, I don't know. 1, 2, 3, 4, 5, 6. 6 frames of animation. And just to make sure here, 1, 2, 3, 4, 5, 6 for the right. Okay. So L0 to 6, oh sorry, 0 to 5, and R0 to 5. So what we'll do, I will just define my const. I forgot what I named it. I think I named it just run in the middle. Run animation max? Yeah, and it was, goodness, was it 5 or 6? I think it was 0 to 5, so it was 6. Define the maximum amount of frames for the run left animation of the player. And, you know, this is a very tailored solution for this particular project. Obviously, if, let's say you wanted to make a puzzle platformer, some different genre of 2D game, your framework is going to look different. But some of the fundamentals, I'm not trying to boast mastery, but what I'm trying to at least utilize is just a few fundamental ideas just to set the scene itself. And usually that's enough to kind of get a project going. And I didn't seem to, I don't think I named that right. Left run, I think I forgot left. Player one left. Left run, and that should be okay, I hope. Yeah, that's fine. And now I'm gonna just change the naming convention. So from J to L, L for left. And I'm gonna quickly grab this. And I'm gonna do the same for the right. So player one right run. And I think it's the same amount of frames. But I'll just change L to R. And I will just define my constant value. Okay. Player one right run. And it's the same amount of frames. Okay, so that's the first phase, I believe. Let's just check, because we have a couple errors, and oh yeah, those errors are to do with the fact we haven't created these functions. Let's go ahead and do that. So we've got the basic assets that we want. I think that's all of them. Let's just double check. We've got run right, run left, jumping, standing, and that's it for the rabbit, yeah. Standing, jumping, running, yeah. And we have the background. Oh, there's one more. We need the foreground. I'll just go back by one. I'll go to the backgrounds, and it's called I'll use the grass texture. I've got two sets of textures. I've got grass 0 and grass 1. I guess grass 0 makes a bit of sense, and grass 1 could be for like a hill or something. Something like that. Or some kind of background, like a parallaxing foreground asset. So let's go for grass 0. And we'll just use the same kind of technique. But because we are just loading one texture. Oh wait, but there's two, isn't there? Grass 0 and grass 1, so I can use another loop. So I'll just say canvas bitmap object. Go back to the backgrounds folder. This time I'm looking for grass underscore index. And I'll change the name of my constant value. Let's call it oops, no, not background. Let's call it foreground grass. Let's just call it texture. Texture. Yeah, that's fine. What was it? Foreground grass texture. Because I'm going to copy this instead. Control D doesn't seem to duplicate anymore. I've realized. Maybe it's a Visual Studio 2019 update. I'm not too sure. I really liked Control D because I don't want to do it now because I'm scared what's going to happen. But one day I was like, what's going on? I don't know. Like, I don't know what happened to Control D. It doesn't do the thing anymore where it just copies and pastes straight away. Anyway, maybe they've changed it. I don't know. What was it called? Foreground grass texture. Alright. And I'll just amend the comments. Defines the... Okay, so let's just say this variable is used to access the grass textures by index. Something like this. Oh yeah, and it's going to be 2, not 6, because we only got 2 textures. Let's see. So for a range of 2, grass 0, grass 1. Let me just make sure that's called grass underscore 0, grass underscore 1. And then with PNGs, PNG file. Yeah, that's fine. Great. Now I could load the grid, but I won't do that right now. It's not that important. Maybe later, just if we want to kind of just see how it looks. A bit of fun there. But let's go to the next step. So what's the next function down? It's animated draw. Very well. Let's go ahead and make a private void. Actually, do we want to make it async? Because I had this issue. Maybe I was thinking about uploading the video. I made an entire video regarding another game project, which you've seen probably on the channel. And I had issues where the canvas draw, animated draw, was trying to load resources that the create animated resource hadn't loaded yet. So I just ended up using like a try catch as a workaround. There's probably more efficient ways to go about avoiding that scenario, but it's really good to use async, I suppose, as a level of failsafe. Animate a draw. We have to pass the correct parameters. And we don't have to worry about any particular assignments. All we need is to access the canvas animated draw event argument, I think it is. So let's go ahead and grab this typed event handler iCanvas control. I think this is what we want for the first parameter. Let's call that sender. Might have got it wrong. It's probably just canvas animated control. I want to grab this as well. And guys, in a hot minute, I'm going to just take a quick pause, and I will be right back actually. So just do give me 1 minute. I'm just gonna mute things and just give me about 2 minutes, and I will be right back. I'm so used to looking forward. Sorry about that. So I will be right back. do apologize for the slight interlude. I am back. Let me just pop the screen over. That's better. Sorry about that. Had to take a quick break. So let's get straight to it. Where did we get up to? So, goodness. Oh yes, we were passing the parameters here. Canvas animated draw event args. I think the first one is wrong. Let me just close this. Okay, let me just quickly check what the first one should actually be. I seem to be missing something there. So it's the animated draw. And I'm just gonna check now, just off screen real quick on my notes. Quite a lot of notes, so I have to just scroll up. Just trying to find the function. Animated draw. Scrolling. Ah, I found it. Ah, okay. So I'll just quickly get rid of the brackets. So you want to pass the iCanvas animated control interface. We can just leave that as sender. I could say iSender, but it's fine. Okay, so everything here is all the functionality in this function is basically the main draw loop. Runs on the draw thread. If I can, I'll get the documentation up really quickly. The documentation on the official GitHub actually has a really neat diagram which tells you how the threading consideration should be taken into account. I'm just going to see if I can find it really quickly. If I can't, then I will leave it. Canvas control, Microsoft Graphics Canvas UI. In fact, let me just show you guys what I'm scrolling through. So I'm on this very handy page. This is what we're looking for. Canvas animated control, I believe is this. So let's have a look at what the documentation says. So if we go to, I'm tempted to go to that draw event, but let's go here first. Okay, it's not this one. Let's quickly go back. It's always good to look at the official documentation for reference. I'm not sure if it's going to be on this page. No, I can't find it. It's somewhere here, but again, I'll leave the important links in the description. But it just takes in, if you want to kind of consider how the threading works, there's a really neat diagram somewhere there. And I had a look at it and I was like, okay, that's really good to know. Because yeah, you can get some kind of like threading. Obviously, when you're dealing with threading, it can be a little bit sticky sometimes. So basically, all your animated logic wants to go in here with regards to updating. So if you have any kind of idea of the concept of update loops, you know that an update loop kind of just runs indefinitely as your game is running, and you can put particular logic that will just keep running and keep running and keep running. So it's quite interesting that we have two particular loops that does this animated draw, and I'm just about to make the animated update. So I'll go ahead and grab the name there. Yeah, make some space. Private async, oops, void animated update. And the way I like to use this is I do all the drawing logic in animated draw, and anything else like checking for game state and stuff, I tend to use animated update. So let's see. Chances are we're going to need the iCanvas animated control again. It's quite a similar functionality. And we're going to pass the canvas animated update event argument. Let's just give this one a name. And then right here, I'll call this one E. Whoops. I meant to do Control S. I hit D instead. And there we go. So now we basically have, let me just quickly check off screen to make sure OBS is fine. Yeah, OBS doesn't look too bad, but the text is a little small. So yeah, what have we done so far? We have defined our canvas animated control. We've set up our three events: create resources, draw, and update. and we've made the hooked functions to the respective events. So at this particular point, nothing is going to get drawn on the screen. We've only loaded the resources into memory at this point via the create animated resources. So now, considering the flow of how we want to access our graphics, once this has completed its executing this logic, the program will turn its attention to the animated draw, in theory. And what this means is that we can call, in this particular case, the E, and E is just basically an instance of the canvas animated draw event arguments class. And we can access a particular property called drawing session. And if we go into drawing session, we have a range of properties and functions that will help us with regards to drawing. So I tend to go for draw image if we're dealing with sprites we want to draw on the screen. And now, since we loaded all of our assets into a list, sorry, we can actually access everything at global scope within one collection. And I think it might be handy to just have a little reference to the indexing. So what do I mean by this? By this point, the canvas bitmap object list is empty until we populate it here. And so it will be, we can consider this element 1 because we place one object in here. But we have a loop looping twice. So this means that there are now 2 elements. So actually, let's just say 2 to 3. And some more coffee actually, excuse me. What we'll then do, we know that we're looping through 9 times and adding to the list 9 times basically. And this is where my math shines. So it should be, if I'm not mistaken, 4 to 13, 9, 10, 11 to 13. Yeah, that's fine. So at this point in the logic, this canvas bitmap object list is looking at populating the 14th element, and we know that there are five loops that we want to add. There are 5 loops in the for loop where we're going to be adding bitmaps into the canvas bitmap object list. Excuse me. So what we can just do, just to make things a bit easier for us, we can just say 14, and I hope I'm taking into consideration where's that TV remote, because right now my monitor display might just turn off unless I change it. So I have to activate it there. Sorry about that. What am I saying? I'm just hoping that my indexing is correct. So 1 and 2, 3. Yeah, that's correct. So 14, I thought it might have been 4, 13, 13, 4, and so on and so forth, but it doesn't matter. So what's this one? 5. 14, 19, I think. 18, isn't it? So, yeah, my maths is so poor. Yeah, just make sure. Wait, was it 5 or 4? Oh, it was, yes. I'm not even gonna lie to you guys. I got it right the first time, and I copped out. I was too afraid. Anyway, 14 to 19, and on a more, serious, no, not really serious, but if you get this messed up, like these indexing, then you're gonna basically load graphics in like different rectangle bounds that we're gonna be loading later, and obviously it's gonna be very visible on the screen when you're rendering a tree, when you should be rendering, I don't know, a background or something like that. So yeah, we just want to make sure we're doing this fairly accurately, basically, so we don't have to come back and correct things. So this is 20, and how many frames are there? We have 6 cycles, so we're going to put 20 to 26. And then it's going to be 26 to 32, I think. So, alright, that's fine. So, by this point, what we want to say in our animated draw, let's just say, before we start adding like physics or anything like that, getting to that point, we just want to make sure everything draws. So what we're going to do, we're going to call the draw image function, and there's a ton of overloads. We have like 19 different overloads. There are 19 different ways we can load our graphics. And I think it's number 2 that I want. Yeah. So number 2 accepts a bitmap, canvas bitmap, and a rectangle, a rect struct destination rectangle. And this is just the bounding rectangle that will hold the sprite, the dimensions, and the positions. So we're going to make a list to hold all of the rectangles we're interested in. Right, so what do we want to do first? If we want the background, we know if we just kind of look at our notes and code, the code notes, we know that we are loading the forest background first, and we just know that's indexed at 0. Ha, hold on a second, guys. Yeah, 0 indexed. Yeah, so that's my fault because I went and put 1, and I think that's just a simple mistake to make. Because, yeah, so that should actually be 0. Sorry about that, guys. I went ahead of myself. So I should probably just correct this quickly. Let me not get confused now. So 0, and then let's just do this from scratch. So 2. Okay. See, I was actually getting confused there. Let me just amend it. So what I did, just in case you're not too sure what happened, I forgot about the 0 indexing. So I just have to just make sure. And sometimes it's not a bad thing to get these things wrong, because that's what debugging is for, isn't it? To just kind of expose what what I might miss. You know what, and a developer might miss. 25. Oh, and yeah, I know I've done something wrong there. Because that was already 26, so I'm not too sure. We're gonna see what happens when we run this. I'm already getting confused. And this is just a notation, so it is important, but we just have to hit the right indexes. So we already know that the background is going to be indexed at 0 because it's the first element in the list. Do we want to play with magic numbers? No, I don't think we do. I don't think we want to play with magic numbers. So, because we're not going to know what's going on. Why don't we do this? Why don't we do it like this? Let's have a local function called void draw assets. And draw assets is gonna draw all the main assets for our general draw core. So we have to kind of think what's gonna be on the screen in a scene all the time. We can consider the background in any kind of simple scene. The background will always be there, even if it's parallaxing. So we're gonna go ahead and let's just say, just to keep this in global scope, I guess that makes things a little bit easier. I have an idea. We are going to have some variables in global scope to just basically easily define by index what we want to access. But if we have a bunch of animations, we don't need to access all of them by index. We just need the first one in the range. So that should be okay, I suppose. So let's make an enumerated list and let's call it background backgrounds. Let's just call it backgrounds for now. I think that's a fair enough name, because I was thinking if we should put the rabbit sprites in this enum as well, but let's kind of keep it separate. And let's just say we want, say, the forest. Hold on a sec. What's the type? Do I have to find the type as well? I'm not too sure. I don't use enums that much. Let's quickly save that. Nah, that's fine. Okay. Because it's already implied by the list, I suppose. So forest, let's see if I can get the syntax right. is equal to 0, and there's only one element in here. Oh, we don't need a semicolon, I think. So this enum list holds the, let's just say, generally holds any background assets that need to be accessed by index. Let's give it a better name. Forest background. Forest background, let's just call it that. Now, I'm gonna make another enumerated list. This time, I'm gonna call it rabbit. Actually, no, let's go with the foreground. Foreground? Okay, no worries. So let's call this one, and we know we have two foreground elements. We have the grass 0 and grass 1. So let's just go ahead and say grass 0 is equal to 0. Actually, this is where we have to be careful. So the trick with this is that the values we're assigning for grass 0 should match the index at which the asset is stored. That way it just gives us complete and utter quick access to what we need without having to do like calculations here and there, or like looking into where things are, adding magic numbers. So grass 0 is indexed at 1, I believe, and grass 1 is indexed at 2. Excuse me. So grass 0 will be indexed at 1, and grass 1 will be indexed at 2. Where am I? So we can just say something like this enum list. I spelled generally low. This enum list holds the foreground assets that need to be accessed by index. Just gonna quickly check off screen very quick. Make sure everything's okay. Yeah, looks fine. Excellent. So anyway, where was I? Yes. So we made two enumerated what a mouthful. We made two enumerated lists, foreground and backgrounds. That's so weird that I call that backgrounds plural, just one element, and like foreground with just one element there. But we might add in the future more backgrounds. Let's make it general for now. And now let's make another enum, and let's call it. Let's be a little bit specific. Let's call it rabbit because it's a rabbit character we have. I spelled rabbit enum. Yeah, and now I need to access the correct index. Now this is where it got a little bit confusing because I was getting confused with my numbers, but a little bit of trial and error might be okay. So we don't want to get we don't want to list an entire enumerated list of every single frame. I don't think that's necessary. We just need the first element. So for the standing animation, which is denoted by this S, if my commenting is correct, it's indexed at 3, and we know there's a range of 9. So we have to just bear that in mind. And we also have this const defining the animation max. So as long as we have the range of 3, and then we can post increment this value by 9, we don't have to necessarily define each and every value because we can just calculate it. So then what we can just say is rabbit. Let's be a little bit more specific here. Let's just say rabbit. I'm sure for these enum lists I should be using like snake case up here as well. Not too sure. Rabbit standing animation start index. I think it's a little long, but at least we know what we're talking about. I think it was 3. So let's just say rabbit standing. Rabbit standing. Let's just call it that for now. It's a bit easy. Rabbit standing is index at 3. And now we just have to do this for everything else. Um, Again, I'm not gonna boast. I'm not gonna say this is the best way to go about it, but for me, it just makes it a lot more easier. So when I'm actually programming this framework, I can just say, okay, I know that the grass texture is index here and it's readable, grass 0. So it just makes it a little bit easier. It depends on the trade-off how you want to go about it. So we're gonna go ahead, make another one. Rabbit. Instead of standing, we're gonna say left run animation start index. Let me just check it. I don't want to go off the top of my head. I might make a mistake. So what was it? Standing. Oh, we have jumping here. Let's not forget that. Let's deal with jumping then. So jumping is apparently 13, and it's got also a range of 5. So 5 frames starting at index 13 in the list. So I'll just change this from left run to jump, and I don't have a jumping in the other direction. I just realized, but maybe we can work around that in code with like some kind of transform function. What was this? Index at 13, I believe. Rabbit jump animation start index. And then now we want left run. Oops. Just double check that's 13. Yep, 13. Jump out for the jump animation. Left run is it starts at 19, and right run starts at 26. So 19, 26. I'm trying to remember that. I'm not going to comment everything just yet, just for the sake of time. What was it again? 1926. And this was rabbit right run animation start index. Okay, so we have some enums. Let's just collapse this. Actually, no, let's not collapse this. I want to see what it is. So now, to make our lives a little bit easier, what we can now do, if we go back to the animated draw, if you remember, we need to pass into this draw image function a canvas bitmap. So we have plenty of canvas bitmaps stored in a list. Which one do we need? Well, we have an enumerated list, which is quite conveniently named, so that now what we can just simply do is access our list, canvas bitmap object list, get our square brackets, access by index, and then we can find the enum, and I forgot what it was called. This is for the background, isn't it? So I think it was something like forest background. Don't even know if I can use this keyword on it. What was it? Foregrounds and backgrounds. Okay, so let's start with backgrounds. Thought so. Okay, cool. I think I have to instantiate the enumerated. Do I have to instantiate it first? Do I need to? Let's just see. I think I can just access it directly. Yeah, that's fine in this particular context, I hope. Backgrounds. Okay, it's not like that. But let me just, I'll come back to that. Because what we have to do as well is, we haven't even started on the rects. So I'll come back to this and I'll do all in one go. So let's go ahead and very quickly make our bounding rects. And we'll call it, we'll start off with a list of rect. And we'll just construct some new list inside of it if we can. Let's call it bitmap bounding, where am I? Bounding rect. I'm not going to construct it here, I'll construct it in constructor level. Oops. And then I'll just simply say, I'll reference it here. Bounding rect equals new list of rect. Okay, cool. So we have a new list of rects. So now the question is, what dimensions and what position values are these rects. We have to decide that. And now, obviously, I want to just quickly get an idea what the scene looks like. But ideally, we have to make like a levels class, which will just sort of outline the it will just describe like the components that make up the level itself, and that will be defined, I suppose, in this particular concept for this very simple game example, a list or some collection of rect structs that hold different assets at different positions and different dimensions. I don't know if there will be enough time to hit physics, but we'll see how things go, because physics is quite an interesting one. So, where was I? We just constructed our rect list, and let's make a function for this. Let's just say something quick. Private void populate rect list bounds. Yeah, let's make it a let's keep it as a void, and it accepts a rect list of rect. Let's call it rect list. Excuse me. And what we do, since we're only going to be right now for this very simple scene, we're concerned with the background. So I'm just going to put it at like a default position. So let's say rect list.add new rect. Oops. Oops, where am I? And let's construct the rect. So I believe the default will be 0, 0 for X and Y. Width height is kind of down to what we want it to be. I was targeting 1280 by 720, I think, or was it 1080 by 720? We can quickly check. 1280 by 720, as it says up here. So let's go by those numbers for now. And again, I don't want to make it magic, so let's just go up. Actually, let's just go up a little bit. Constant. And let's call this display bounds width. Let's spell width. There we go. Display bounds width equals 1280. Just gonna copy this. Copy again, actually. Let's just say define the width of the display for the bounding rect. Actually, let's just make that a little bit more general. So let's just say define a display dimension for the width. Because at the end of the day, we might be working with different dimensions that we might want to responsively incorporate into the program. So I'll just keep that naming, like the commenting, a little bit more general. Display bounds height. And I believe it was 720. Define the display dimension for the height. Okay, so now we can access this in our code. Where was I? Oh yes, here. So now we can just define for the width and for the height as well. Oops, there we go. So that's 1280 by 720, quite a large dimension. And 0, 0, so that will be the top left of the screen with the y-axis incrementing going down physically on the screen, and x going incrementing, increasing going to the right, if I'm not mistaken. If I'm not mistaken, I'm not too sure. I think that's the way. So what we're doing here, we're gonna call this function in the constructor, and we're gonna pass our list, bitmap bounding list, rect list. Oh, I didn't call it list. Let me call it list. Oh, I must. Oh, what am I doing? That's not where it's defined. Oops, I think I missed it. Here it is. This is a list of recs that hold the bitmap graphics bounds. Okay, how am I doing for time? Okay, we're still going. And so what's going on here? Constructor passing this. Let's just put semicolon there. And now, so we're passing the list and we are populating it with a rect. We're constructing a new rect, and this is going to be the background rect. And it's the first element in the rect list. So now, what we can do in our draw assets local function in the animated draw method, we can then basically say this ret list bitmap bounds ret list indexed at 0. Now, because it is 0, I'm not going to go through the effort of just like making another enum. Should be easy enough to understand, I suppose. We want the first element in this particular list, but that's something that should be improved. Now, about this, because it's a draw function, I don't want to construct it here. So let me just, I think I'm supposed to instantiate that. I'm not 100% sure. Background forest. And then if I just say, oh gosh, give me 1 second, guys. I always get confused with this. I'm just off screen real quick. Where am I? Looking for the reference. Because at the end of the day, it just helps keep stuff a little bit more manageable, I would say. Even though it does take a little bit of time, it takes a little longer making the code kind of self-documenting. But I've just found it does help me at least. But everyone's coding process is a little bit different. I'm just off screen really quickly. Okay. Goodness, I did that completely wrong. So, yeah. Whoops. Sorry about that, guys. Brush up on this syntax. So now that should be better, I think. Let me just double check. And then after this, I think we might be safe to just run the program to just make sure everything draws. Just quickly off screen, just checking one of my monitors. Shouldn't take a minute. Oops. I can't scroll for some reason. Okay, so what do we need? Backgrounds. Okay, fair enough. Where am I? I'm gonna put it in a kind of convenient spot. Let's say, and let's call it forest background. And let's go back to the local function. And let's just say forest background. Well, actually, shouldn't be doing it here. So I'll just grab this, copy, I'll leave that there. Hope I'm doing that right. Kind of doing that wrong, and my syntax is off there. Goodness, what have I done there? Let me just quickly check this. Doing that wrong. Connected. Just quickly referring here, and then we'll just move on. I'll admit, a little rusty on that piece of syntax. I know it's pretty simple stuff, and I literally have the syntax in front of me, and I cannot find it. I know that's not going to be the way. It shouldn't be the way. I'm annoyed at that. Just give me 1 minute to just actually let me see how to do that properly. Unless my whole idea behind that was kind of flawed. Ah, okay, I understand. Because I suppose, yeah, I think I went wrong because I don't know the correct terminology, but if I was making a direct comparison for like another enumeration or some form of, let's say, a function that accepted an enumeration of this particular type, which I named backgrounds, then I could do what I tried to do. But I have to, in this case, I had to typecast it to obtain the value, which makes complete sense. So I was a little bit naive there, because you may not necessarily have that direct access to the actual internal value itself, unless you, well, technically maybe you shouldn't. But for now, let's just roll with this. So I just typecasted it, just a long-winded way of just saying index at like 1 or whatever it is, or 0. Can't even remember now. But that's all completely fine, because I think we can compile this. But I'm a little bit wary because I think some of the indexing might be off. Let's have a little look, and then we'll take it from the code if we have any kind of errors in the C# file. It's taking a considerable amount of time to get to this point. And it's funny because every time I do these kind of videos, I always have like an agenda. I don't think I even showed it to you. I promised I would. Let's see if I can get it on the screen. I'm not too sure. Yeah, I think it's this one. So this agenda today, I thought, okay, let's go through Win2D setup, import the assets. We're going to put some gravity. We're going to put up thrust. We're going to do physics. Yeah, we're still like, well, we importing the art assets. And I don't know if I have enough time to get through this entire list, but we're gonna see how it goes. Because it will be fun to kind of move to the next step. And the physics class is always quite interesting, kind of imposing this factor of physics on some object. It's just kind of an interesting concept. And I think I have bought some time for UWP to load Visual Studio. Deploy has succeeded. Let me just quickly see. It might just be off screen. Not yet. I think it's coming any second now. Okie dokie. Sorry by the way, guys. It's just deploying. Here we go. So it might, if it does, if everything is correct, let me just make sure I've done this right. So draw call, loading assets. I didn't put a try catch, so we might get an error because I might be trying to access a resource that's not constructed yet. We have tons of resources to construct, and we have one small draw call, so it's likely we might get an exception. So that's just a heads up there. And I didn't await the functionality, so that completely defeats the whole idea of async. But it might just load. I'm not too sure. We'll have to check. Okay, I'm seeing nothing, and I'll leave that there for now. I'm gonna check the draw call. Oh, of course, I forgot to actually call draw assets. Silly me. So let's just do that now since we've hit our break. So I'm gonna just collapse this, and I'm gonna call void, not void, sorry. What was it called again? Draw assets. Let's call this local function. And the idea is to have all our functionalities kept in like nice little local functions, and we just call them as and when needed. We can make a little bit of a pipeline. Excuse me. Where am I? Let's continue. And let's see what happens. Oh, okay. Let's just inspect what's going on here. I do appreciate it's going to be quite hard to see, and I should have zoomed in earlier, actually. Sorry, guys. So let's just step through. And we have a null object reference not set to an instance of an object. Let's see what the offending code is. Let me just highlight that. I'm guessing we're not constructing this rect. We're not populating it properly. It's not really showing up. Check my locals. Oh, it does say there. So if this is null, it's probably one of our lists. Canvas bitmap object list. It's either this or the bitmap bound right list. I don't think it's the bitmap bound right list. I think it's the canvas bitmap object list, but I might be wrong. We know what I should do very quickly. Just as a quick hot fix, let's just put a try catch here. Just in case, because we have so many resources that have to be loaded, like over a dozen, just from what I can see. And this draw course, since I haven't added asynchronicity, it's not going to really wait, if I'm not mistaken, for the completion of all of this to try and draw this. So we don't need to do anything in particular here, but I will add an await. Zoom in so I can just see a little bit easy. I'll just keep that there for now. Yeah, I think that's awaitable. And let's just stop the debugging session. Is that... Can I await void? Oh, okay. Is this an awaitable function? Void, drawing session. Okay, maybe not. Okay. So, I will just fall through with the try catch then, if at all, and then once the resource, if it is the resources failing to load on time, then it shouldn't be an issue as far as the resource call is, the resource function completes. So this will just be catching until the resources have finished the functionality. So I'm going to collapse this, but then it could be that I'm not populating the right list. So let's just see what's going on. So we'll just kind of restart the application and have a look. I'm just going to look at my constructor as well. My bounding red list, I'm constructing there. And I'm populating it here. I'm adding new. So this shouldn't be null as far as I can tell. But we'll see in a second. And we'll just kind of observe the output window. Probably going to get exceptions. So yeah, as expected. Exceptions. But yeah, this is what I mean. So those initial exceptions are expected unless I can find a better way to deal with them. But for the most part, we have our meadow. We have our background. And it looks pretty. But, you know, it's just a very simple scene. This is just step one. I don't really want to full screen it, but I will. Yeah, it clips heavily because obviously it's outside the bounds of what we're working with. So, but here it is, a simple background, not bad. Now, let's see. We have other assets, so why don't we try to load some more? Let's start with the grass. So I'll just wait for, I'll actually press, no, I don't need to, do I? Okay, no, it's fine, okay, cool. So in the animated draw, now that we've kind of set the overall framework, it makes it a lot more easy. Let me rephrase myself. It makes it easier for us to actually kind of extend what we're doing here and to, I don't want to use the word modify, but to kind of to add the functionality that is necessary. And if we keep to the essential fundamental patterns that we are kind of laying down here, then it just means that we run into a more cohesive framework, which should be a little bit more flexible with us when we're trying to implement more features. So where was I? If we go to animated draw, why don't we just let us draw void. But then if I named it draw assets, why don't I draw everything? Let me just see what's in here. Unless I want to be specific, I can say draw backgrounds. E.drawing session, drawing Um, okay, here's what I will do. Because we know that there's only one frame of animation for the background and foreground objects, I will just use this functionality. So I'll say e.drawing_session.drawImage. Could have just copied all that. And I'll copy and paste that. But this time, what we want to access is not the forest background. We want the grass foreground. What did I name it? It wasn't that. That is a constant. I'm trying to look for the enum. So I forgot what it's called. Let me just try one more time. Let's just filter this. No, that's definitely not it. Okay, let's just go up. I did forget the name. So, what enum was it that we needed? Foregrounds. 1 and 2. Because there's not a lot of them. Let's just draw them straight. Could use a loop. Really should use a loop. Okay. Wait, let me try something here. Okay, that works as well. Why don't we just do it like that? So much more easier. But then, are we going to run into issues? No, I'm typecasting it, so it should be fine. So I didn't really have to create an instance. I guess for more complex situations, you could do that. So let's just reference forest background straight away and just typecast it as it ends. But yes, let us not forget that we have to address the correct bounding rectangle. So basically, we are taking responsibility for the scene itself. The scene won't just make itself where we want it to be. So us as the developer here, we have to decide the design of the layout of the stage. You know, we have to do with the level design, which is the layout of the stage basically. So this is where that debug grid would have helped a little bit, just to help position things, and I could draw it on the screen actually, and I think that wouldn't go amiss. So if I just say, I don't really want to put it in the draw assets, but just for the sake of speed, draw image, goodness, I forgot, I don't know what it's indexed at. I didn't even load it, did I? Okay, let's quickly load our debug grid. It should be fairly to scale. And I say fairly because when I made the grid, I used like pretty thick lines. So I didn't want to be like, I wasn't going for precision as much as I was going for estimation, really. And this is just going to be on 27 because it's just one particular asset, which means we don't need a loop. Let me just bring this backwards a little bit. Let's just say, number 27. And just so we know, and it's stored under debug assets. I can't remember the name of the folder. Yes, debug assets. So, and the name of the grid file is, I'm just gonna copy it. Copy. Check it's a PNG. Yeah, and it's conveniently it's actually 1280 by 720. So the scaling should hopefully be fairly okay. So debug assets. This 1280 by 720 grid lines. And I'll just concatenate PNG assets, debug assets, 1280 PNG, index at 27. Okay. So what we need to do is, if we go back to our function that creates the rects, make sure my sound is actually working. Okay, that's good. What we can do, simply populate the rect again, and again, it's just one asset this time. It's the I was just considering, should I load the grid first? Kind of makes sense to do that. So so let's just make it so. I don't even have to change anything there. So how are we doing this? We need. Okay, this is where a loop might come into play. Just so we can lay it out first with, and we can eyeball it and then see what needs to be looped, if anything at all. We're gonna add, construct a new rec to add to the rec list, and this first one is gonna be for the debug grid. So let me just see. When we're accessing the rec list, was I using an enum? Nah, and this is the problem. See, I was using magic numbers because I got lazy. So at the very least, I could just use like variables. I'm not going to use an enumerated list, but I will, because it's not really a list we need. We just need a variable in this sense. So let's just say private const int goodness, what was it again? It was the grid. So we could just say something like grid index. I'll say debug grid. Debug grid. Oops. Index. Just so we know the dimensions, 1280 by 720. And this is going to be 0, because it's the 0 index of the list. This variable is, it's not, let me not say variable. So this value is used, this const value is used, oops, to access the debug grid held in the list. And since we're here, we're going to need another variable, excuse me, to access the background, since I left it as a magic number. But do I already have something? I have it here, forest background. The enum list generally holds any background assets that needs to be accessed by index. Yeah, okay, cool. I should really keep to the convention. I'm kind of making things messy now. If I'm accessing graphics and I decided to use enumerated lists, let's stick with that. And since the debug grid, I wouldn't necessarily call it a background. It's more like an overlay. But let's keep it in backgrounds for now. It'll be a little cheeky. So let's just say, let me put it after this. Let's say, okay, debug debug grid is 1. And now what we're going to do is just, oops. Oh, whoops. Okay. Yeah, that's fine. So now, so what have we got here? Background and debug grid. Okay, cool. So we'll go back to the draw core, the local function in the draw core, and we'll access our enumerated list. So let's typecast our backgrounds enum. I don't really like the way I spelled that in all lowercase. I think it should be like all uppercase actually. I think most enumerated lists are named like that. I might be wrong. Let me see. Let me just have a quick look after this. So what was this one? This one is, I think it's the background. Yeah, forest background. Let me just change this so I don't get confused. Oops. Debug grid will be afterwards. My mouse is a little stuck. Oh my goodness. I need to move my mouse. Sorry about that. Okay, so forest background. Let's make sure we've got the right indexes here. So within the canvas bitmap object list, we know forest background is the first element we load, but actually the I made a mistake. So the enum should actually hold, I think it's 27 for the debug grid. Oh, why am I getting confused? Sorry guys. This is a thing. Should we be using the same when referencing two different collections? Should we be using the same index variable? The answer is probably no. But if they're the same value, we can get away with it for now. Only for time, it's not the best idea. So forest background. Okay, let's just say for now, we use the same forest background. But for the debug grid, it's a little different because the debug grid is stored as 1 in the rector list. But in the canvas bitmap object list, it's not the first, it's not element 1, it's actually element 27, if I'm not mistaken. So we have to be careful with that. So let's just verify that. 26, and no, sorry, not. Oh, okay, it's actually 33. I got that wrong. So for the canvas bitmap, it's 33. So what shall I say here? If these enums are holding the values at the index values for the canvas bitmap list, I suppose I want a different object to hold the rectangle list. Display bounds. This is used for the rect. So what I'll do for the canvas bitmap, I'll use the enums. And this way it gets a bit weird, man. I'm really sorry about this, guys. But I just want to make it a little bit easier for me to see. Again, it doesn't really matter which way you go about this, but there is an optimal way. Goodness, debug grid. I'll say rect index, or rather rect list index, and it's 1. Refers to the, so this constant int value refers to, I'll go back, this const int, I guess it's a little clearer to read, refers to the index of the debug, or rather the rect struct holding the debug overlay bitmap graphic. And now we're going to use this when we index our rect struct, when we want to define the position and dimension of our overlay for the debug grid. And that should be in the draw core, in the local function draw assets. So let's just do that here. So I'll get rid of this. Make sure that's right. So this one is 1. Yeah, I think that's correct. First background is 0. Let's just double check that because oh my gosh. Debug grid ret list is 1. This one should be 33. So we just have to be careful with our indexing here. Right, so let's check our draw core now. We should be, if everything is okay, we should be drawing a forest background, a grid, and a grass texture. Now the thing is, the order in which we call the e.drawing_session.drawImage, every time we make these draw calls, 1, 2, and any other amount of draw calls, the order is important because the order at which we call the draw call will determine the order in the z index at which for what image is being rendered. So if we have, say, background, foreground, and player character, we have to make sure we define, generally speaking, the background has to be drawn first, and then the foreground, and then the player character at the front. So what do we have here? We have a background, we have the debug grid, and we have the grass. I would prefer to have the debug grid as an overlay, so I'm going to just grab this draw call, and I'm going to put it last. And I'll just close that, close the space. I see a 0. I see a magic number. What's going on? Canvas bitmap, grass. Okay. So the grass in the canvas bitmap. Have I defined the grass in the rect? I don't think so. So let's do that now. The thing is, this is not too optimal, but the consolation is that this is going to be different. So we can decide, and this is where the levels class comes into play. We don't want to, in as much as we want to perhaps separate the concerns, you may opt to have a levels class, which then constructs all the bounding recs. Because I want to just demonstrate a really simple scene, I'm just going to do it here and now. And I will make, oops, Control S. I'll just again define some constant value. No, I don't want constant values, because they're going to change for the rect. For the any parallaxing asset, such as the background or the player, will change. So we don't want to define the rect structs generally by a constant. It just occurred to me now, unless it's the overlay, which we want it to stay still. So let's quickly just see if we have to change anything in our draw core. So for the background, where is it? Let me zoom in, guys. I have been zooming out for a while, and I'm sorry. So the bitmap bounding ret list, where's forest background? There it is. Well, for the ret list, I'm using the enum list, the enum int. So that's fine. Is that modifiable? Is it mutable? I don't know. Maybe. For now, we'll leave it as it is and just see what happens. Just in case. If it's not mutable, then we'll just deal with that with just a normal variable. As for the grass textures, I'm not going to use const values. I think it'll be fine using the enum. Did I actually make an enum for the grass? Foregrounds, backgrounds. It makes this as a foreground. Oh, it's already here. So I just forgot. So let's take grass 0 within the foregrounds enum list. Where am I? I'll go down a little bit. So first things first here. Okay, I'm using it here. So I just have to be careful with what I'm dealing with here. So as far as the bitmap object list, I'm saying it's populated at index 1. I need to make sure that's correct. Where is grass 0? So again, we have to just be careful. So foreground grass texture is indeed 1, so that's fine. As for the rect list, we want to define that as, I think it's number 2 or 3. 0, 1, 2. So let's go ahead and define, okay, I see what I mean. Okay, it doesn't really matter. Okay, so let's just do this. Because if we are accessing the recs by index, it doesn't matter. They're not going to change really at runtime. What I was actually concerned with was the values themselves. Private const, and I probably have this already, but let's just go with this. Private const int grass 0, oops, rect list index equals to 2, because it's the second it's the index 2 element in the list. This value accesses the rect struct stored in the list. I might be going overboard with this, but I guess it just makes it a bit more readable, and I quite like that. So not here, but in the draw core. Want to make sure we're indexing. Whoops, my mouse is stuck again. This, want to amend that to 2. And now we just have to consider where we want to place the values, what values we want for the height, width, and the position of our grass texture. So it's quite simple with the grid overlay in the background. They're just like 1280 by 720. But this one, let's give it a sort of, let's give this a more sensible, let's give it a sensible, set of dimensions. Now I know I'm breaking convention, but because I am a little conscious of time, let's just write it in. Let's write it in for now. Goodness me, not great. 600, and then if there's time, I will make variables for these if I can. But for now, it's already 2 hours of streaming, and we've only got into drawing a bit of the scene. Is what it is. So 600 for the X, I think it is. I think that's a little too much. Let's do something like 120. 600 Y going down from the top, and let's give the grass texture a bounds of 80 width. Oh, it's the grass, isn't it? Not the hill. So in that case, it's going to be quite thin and narrow. So let's just say maybe like 30, 25. 25 height. Oh, sorry, 20. No, I'm getting confused. That was width. 40 width, 25 height. And let's just see how it looks, and we can change things according to what we like. And we're adding that into the list. And I think we have one error. Let's check out what the error is. Where is it? Oh, yes. I forgot some stuff here. So, let's see. Oh, yeah. 1, 2, 3, 4. 1, 2, 3, 4. Oh, okay. So that's the construction of the rect. And yeah, so we're not really dealing with update logic right now. With regards to the animated updates function, we're really focusing on the draw calls, the animated draw loop. We're gonna go ahead and we're gonna run this program. So let's just run the local machine. Good to target x86, or just make sure it's not any CPU. Well, you can do any CPU, and the deployment will be a bundle. That's another thing. But I tend to just go for x86 because it's just a little simple. Okay, so that's going to take a little while. Let me just check what's going on off screen. Oh, I think I hit an exception, did I? No. But let me just stretch out the output window. Zoom in on the code ever so slightly. It's easier to read. Make that a little easy to read. It does take a little while on my laptop to deploy, and it is in debug mode as well, so that makes it a little longer. And let's just see what happens. Hopefully we'll have all our assets loaded in order. Not too sure. Might have made a mistake with the indexing, actually, with the canvas bitmap. I was a bit worried about that. Okay, so we have some stuff there. The grass texture has been loaded. Let's move my mouse. It's really small. I don't even know if that's 25 by 40. I'm gonna just quickly go to let me quickly see this, and I want to go to the draw call. Probably best just hit the draw call up straight away, and I will just get the game up again so we can hit that break. Now that's funny. Why is that break not hitting? Let's leave that there. Okay, here we go. Probably getting it. Yeah, oh, I just noticed the output window. I think I'm getting an out of range exception. Let's see, my indexing is incorrect, and that's why the overlay is not showing as well. Forest background should be fine. The grass is okay, but it's not really right. Um, I'm concerned about the bounds of the rect. I'm targeting out of this list here. I'm targeting this value of 2. 1, 2, and it's actually correct. It's just my variables are really small there, so I'll just increase the dimensions. As for the debug grid, this is where I'm probably making a mistake. Yep, catching. Let's have a look. So I was not sure about this number here, and let's go in. Let's expose the canvas bitmap object list. Excuse me. There's actually 30 elements in this list, not 33. So I'm out of range. So I counted wrong somewhere. Goodness me. So why don't we just go here, amend this. Obviously, we'll have to restart the program. Or do we? Yeah, we do. Okay, cool. And I'm going to check the rec list, which should be okay, I think. 1, which is fine. And let's just restart this and see what happens. So somewhere along the lines, I've miscommented, but that's not really the biggest issue. It's any indexing that's incorrect that I may have referenced. We have to just deal with. So I'll just get rid of my breaks. Actually, let me stop the program. I was just gonna change the size of the grass actually. So let's just make that a bit taller. So I'll make this like 120. Is that width or height? Width. And then as for the height, so 120, and let's just say like 80. I'll say 90. Let's have a look at this. My coffee is really cold now. It's abandoned my coffee. And then we'll see what we do from here. Background, grid, and grass. So yeah, that looks okay. Of course, the grass texture is really small, but that's just how it is. Unless I define, more grass texture, I'll just stretch it out. Let me just squish my little window. No points full screen in this actually, to be honest, because it's just gonna clip. As you can see, the white bounds there. So let's just kind of get it nicely in the box. So the general idea here was that, excuse me, is that I wanted this debug grid to just help basically with, because we're dealing with values, it's like we are drawing using a typewriter, aren't we? We're not visually seeing via like a XAML designer what we're doing. We're actually just, unless you map it out somewhere on like a canvas or something, you won't really know where the values pertain to on the screen. So this grid was just a bit to help. So let's see if it's any good, because I went ahead and I estimated 600 to be the Y position of the grass. And if I said 120 for the X position, and I think I'm a little bit off. I was a little bit generous, a bit lenient with my lines. Because unless it's because there's a lot of negative space. If there's negative space with this particular texture, it means there's more space up here. So maybe it starts around here or something, and I think that's the case. Maybe, not to try and make excuses, but so it's something to just bear in mind actually. So if I just go back and we just inspect backgrounds, you'll notice that grass has a lot of negative space. It's a bit hard to see. If my paint.net software it's not that deep, but you can see it. Hopefully you can see it. I was going to pull up paint.net, but I don't want to kind of slow down the computer. But there's a lot of white space there above the grass here, and all of that space is being computed as like alpha transparency, which is fine, but there's nothing that's stopping us from just literally cropping this image here. And then I think that's why 600 is not exactly here, but it's more or less somewhere here because we have all that negative space. So the grid I'm fairly happy with. What was the x-axis I said? Was it 20, 120? 120. What are the dimensions? Is it 1, 2, 3, 4, 5, 6? So every intersect is 100. So 0, 100, and I suppose this is just roughly 120. So it looks fair. And we can use this to help us just kind of, structure our scene. Guys, I think I'm going to leave it here for the stream for tonight. It's been 2 hours. I would love to continue, but let's leave it here and let's continue with this series perhaps with the next live stream. So I really appreciate that you guys have tuned in. Hope you learned and gained a little bit of value in terms of how to use C# and Win2D. We just went to we only went to the level of constructing a simple scene, but even that was quite an involved process, I think. So if you didn't know the process before, hopefully you would have gained some value out of this short tutorial. Thanks very much for tuning in, and I bid you all a great day. Thanks very much. Bye-bye.